Mirrors. Mirrors. Super cool. Let's see if we can do these. We got three kinds. Plane, concave, and convex. We're going to see if we can have this make sense. And it's going to help us when we talk about mirrors as well. Cameras, like this, all this optics stuff. Mirrors, we're going to have to go over a few things here. So we have a mirror here. Now there's something called a focal point. A focal point, let me show you a focal point. Let me redirect this light here at this screen. This is a concave mirror, concave, math word, right? Concave. Can you see? Maybe it was better. Maybe I point it this way. Maybe on the dark. Here we go. All right. Trying to get that light. You see that I'm pointing? If I wanted to fry an ant, I'd put it right here. If I want to fry that ant, I put it right there. You see there's a focal point. I'm redirecting. I'm channeling the light to a point. That's called a focal point. So I got a concave mirror, and there's a focal point. These are some terms we have to get used to. So a focal point is when you redirect light, and it all goes to the same spot. Not all mirrors, and we'll talk about lenses in another lesson, not all mirrors have a focal point. Where's my big mirror? I had it here. Here it is. This mirror is called a plane mirror. Does it have a focal point? Could I fry an ant with this mirror? No, I couldn't. Look at that. Woo! All right, I could not fry an ant with it because the light's just as big as it was. Unlike this mirror here, where I can make a focal point with this other one. So first of all, not all mirrors have focal points. Not all lenses do either. If you want to do a measurement, because science likes measurements, if you want to measure where the focal point is, it depends how hard the mirror is bent. So this is called the focal length. You would measure the focal length to the focal point. This is big with cameras and things like that. Now, a real image versus a virtual image. If there's a focal point, if there's a real focal point, we call the image it makes a real image. If there's a real focal point, a real thing to be measured, a real distance here, we call it a real image that's being produced. Now, let's not get confused here. By real image, we don't mean that the image is actually going to talk back to you. Mirror, mirror. Oh, it's not just an image, it's a real image. This is amazing. No. We're not saying that. All we're saying is that there is an actual focal point that we can measure. If there is no focal point, then we call it a virtual image. This is not a concave mirror. So we have the light coming in this way, and it hits this, and it bounces out. Okay, it's a reflection. Seems reason. This one bounced in to a focal point. This one bounced out. Could you fry an ant if the light shoots out? We need the light to converge, not diverge. So this mirror did not make a focal point. It has no focal point at all. Can't fry an ant. We could pretend there's a focal point. Where would you pretend it to be? We'd we'd have to imagine that the light crisscrossed behind the mirror. But it never went behind the mirror. That never happened. That's fake. Fake news. The light never went back there. So that's not a real focal point. Fake focal point. But we sometimes imagine one there anyway. Why? Why would I imagine a focal point that never happened? So I can have something to measure. Because scientists like to measure. They say, well, this is a mirror. What can we measure about it? Well, we can't measure the focal point. Well, if it did have one, it would be here, though. Okay, well, let's measure that then. We'll measure the pretend focal point. So it has a fake focal point that never truly happened, but we can imagine one. And so they put it there. If I work at a mirror factory, and somebody wants me to make this bent mirror here, and they say, we would like a mirror. Okay, convex mirror. I can make a convex mirror. How bendy do you want your convex mirror to be? They could tell me the focal length, and I could It would be a fake focal length, but at least they could communicate. That would communicate to me the bend I should put in the mirror. Even though it's not a real focal point, I can design it to what they want. So it's useful. It's useful for me to produce it, and for me to communicate with that person, how bendy they want it to be. All right. So that would be called a virtual image. Real image means there's a real focal point. Virtual image says, well, it's a mirror, but it doesn't actually make a true focal point, but we still have to give it a name. So let's talk about the three kinds of mirrors in this segment. A plane mirror is a flat mirror. You can't fry an ant with a flat mirror. When you look in your bathroom mirror, that's a plane mirror. It makes virtual images. There's no focal point. The light doesn't crisscross. You don't get to a certain point, ow, my eye, I got into the focal point. It's frying me. It doesn't. So that's a virtual image. And virtual images have no focal point. And if you're right side up when you look in your mirror in your bathroom. You're not upside down in that mirror. You are the same size. You don't get bigger or smaller in that mirror. So if you're standing 2 feet back from the mirror, the guy in the mirror yourself is 2 feet back on the other side of the mirror. Everything's always equal. You get close, your image gets close. You get far, he gets far also. Everything's samesies in a plane mirror. All right? So plane mirrors, no focal point. The light doesn't come together. And everything stays pretty much the same. The DO stands for this is the distance of object, and here's the distance to the image. And so if this is 2 feet, this is 2 feet, they look like they're 4 feet apart. It's 2 feet and 2 more feet. This guy moved back 5 feet, well then this guy moved back 5 feet. It would look like you were 10 feet apart because the distance from the object and the distance to the image would each be 5 feet. This is how mirror people talk. Let's get to concave mirror. Concave mirror I think is kind of fun. Concave mirror. This is a concave mirror. Let's see what this looks like. How does it look like in the camera? All right, I gotta get some lights on in here. All right, I don't normally do it. This is a camera, so you gotta. All right. Now I want you to look closely. That's. Look how everything is. Where are the desks? Look at the floor tiles. They're all where? Upside down. Everything's upside down, right? The ceiling's on the floor is on the ceiling. Now, but look at my hand. See my hand's reflection? See my fingers? Are my fingers upside down in the mirror? Can you see? I know. My hand's exactly where it should be. Look at the reflection. So my hands, my fingies are right side up. But everything else is upside down. Now watch and be impressed. As I pull my hands back, watch what happens. Now what has happened? My hand is now upside down. It eventually goes upside down. You see it? I'm trying to keep it all aimed right. It's usually better when I don't have to worry about the camera. So my hand's upside down, and now my hand is right side up. When did that flip moment happen? It was fine here, upside down there. Fine, upside down. It's when that focal point happened. That's where the light crisscrossed. The light crisscrossed and went upside down. So that focal point determines when things flip. It determines when things flip. Now, if there is no focal point, there will be no flip. If there is no focal point, there will be no flip. There has to be a focal point. The focal point has to have happened. You have to pay attention here. All right? So if you're just texting right now and just have me run in the background so you can puzzle me through, we've got to pay attention here. All right. If the light, when there's a focal, this is the focal point right there. That's the focal point. All right. This is the top of the object over here. That's the top. Ignore the screen. Here, let's turn the screen on. I don't want you watching the screen. This is the top of your image. Look, there's a tall ogre, and there's his head, and there's his feet. The top light is up there. The bottom light is down here. There's his feet. Now, as that light comes from him, and if it crisscrosses, if it ever crisscrosses, now his head is down here, and the light from his feet is up here. The light is switched. The light is switched places. Top is moved to bottom, and bottom is moved to top. Because this point here is called the focal point. It's switched places. Does that make sense? This is where I'd like to check for understanding with you guys to see, does this make sense? What kind of questions do you have? All right? But the focal point moves the top to the bottom and the bottom to the top. Mirrors can do this. Certain mirrors can do this. Concave mirrors can do this. And lenses, certain lenses can do this as well. You have convex lenses. We're going to talk about that another day. But a concave mirror will crisscross the light. Crisscross applesauce. Okay. Now, small or big? Let's look at this. Let's go back to this. Are you big or small? Are you big or small in that image? Well, I know, it's the camera. I get it. Are you big or small? You're small. Why? Now, imagine how this is going here. If light comes to me like this, or if light comes to me like this, it's going to make it different, big or small. Let me explain. If light comes to me like this, the top of the object is here, the bottom of the object is there. I'd say, wow, that's a big guy because his head is way up here and his feet are way down there. If light comes to me like this, spreading out, so instead of converging, it's diverging. Now my brain says, well, where's his head now? His head is down here. His feet are right here. Is this big or small? Head, feet. Look at the ends here. Small. So if the light is spreading out, I think this guy's pretty small. If the light is converging, I say this guy, his head, feet. So you have to look at what the brain would say. If the object's coming from a wide angle, we say that guy must be pretty wide. If that guy's coming from a narrow angle and the light's diverging, if it's coming from a narrow angle, we say that guy's pretty narrow. So we come back to this picture here. It'll get brighter in a second. And if this is, we're gonna talk about this again when we get to lenses in a future segment next week. But the way this light is coming to her is the light is spreading out. So it hits the mirror. It's kind of jumbled how they drew it in this picture, but it's spreading out and it's coming from a narrow angle. It's coming from a narrow angle, so she imagines her image to be narrow if she's in one spot, and it's big if she's in another spot. All right. Watch this. Let's play with this thing one more time here. Look at her hand. Her hand is big. She's inside or outside the focal point with her hand. Is she inside? Is her hand inside or outside? It's still right side up. Has the light flipped? Has the light flipped here? If it's right side up, the light hasn't flipped. There hasn't been a focal point. There's been no crisscross. But here's a park bench at a park. The park bench has flipped. So that means that the park bench is outside the focal point. So if I have my hand here, I'm inside the focal point, and my hand's big and right side up. If I put it here, my hand's small and upside down. This part, the focal point hasn't happened for my hand. It hasn't happened. That makes my hand's image a virtual image because there was no focal point for my hand. There was no flipping of light. But once I pull my hand out, the image flipped. That means a focal point happened, which makes it a real image, and it's small. Now the light is it's small, so that means the light is coming from a narrow angle and spreading out this way. We're gonna save some of this clarification and review. We're gonna review it again when we get to lenses. So I don't want to overhit it here and then underhit it there. I'll leave that on and that off. Go to the next slide. So concave mirrors, focal points, all right? The Vidara, we watch this YouTube, if you can always look it up, Vidara death ray if you want, but this is a concave mirror. It was frying people down in the swimming pool when the sun was at the right angle and horizon and time of day, and it melted some people's plastic objects and they had to redo the windows to make them not as shiny. Whoops. All right, anyway, this is a convex mirror. Convex mirrors, the light will never crisscross. So it never goes upside down. You can't make it upside down. It's always going to be right side up. With concave, you could do either or just by being close to the mirror or away from the mirror. Being inside the focal length or outside the focal length. You could play with the focal point. This one has no focal length to play with. So it is always going to be right side up. The top light always stays on top. The bottom light always stays on bottom. So it's always going to be right side up. And since the light's spreading out, when you see it, it's coming from a narrow place. In our mind, it's coming from a narrow place. Well, the object must be narrow. That's why we put convex mirrors on buses and our car windows, and we say objects in mirror are closer than they appear because the mirror made it look smaller. It gives you a wider scope of field, but it has to shrink everything. And that's a convex mirror, will shrink it, but it'll never put it upside down. So that's a convex mirror. So I think, is that where we, oh, that's a scary scene from Poltergeist. Talk about real images. So there's Heidi, and she is little in a fun mirror. So anyway, we're going to take a look, you're going to take a look about those things, we're going to read about those things, and I hope it makes some sense, and we're going to learn more about, we're going to return to this idea of virtual images, real images, and focal points when we talk about lenses. But that's for another week. Hope you're doing well. Talk to you later. Bye-bye.